So for our last scenario here, we're going to be looking at completely replacing the conventional generation with renewables. So in order to do that, we need something that can be that frequency and voltage master for our system. And many battery energy storage systems that have that grid forming capability are going to be able to provide that service for us. So what that'll allow us to do is then back off the conventional generation completely and run on batteries plus PV. So what we're going to be doing there is reintroducing those batteries, making them available to the system to control. And then once the system recognizes they're available and are sufficiently charged for our purposes, then it will use those as its preferred resource and switch over to use the batteries and back off and turn off the conventional generation. So let's take a look at what we can see with the wave controller in that for this scenario. Okay. So kind of back where we were, we've got one generator online providing that frequency and voltage master service. We have our PV online. We're using as much as we can. So now we'll go ahead and switch the battery over to be remotely controllable and available to the Wave microgrid controller. And as we see those become available, we'll see Wave brings them online, closes the breaker, and starts pulling power from them to meet the needs of the system. And when those now are available, we see that it's backed off the conventional generation, shut that down. So now we're operating in a purely battery and renewable operation to meet our loads. And as long as that there's enough renewable generation available and we have sufficient charge in our battery, we'll be able to operate here as long as we can. If we're in an island state for long enough and there's a cloud or the sun goes down and that PV no longer is available, then we'll bring back in that conventional generation. Again, the main priority is to keep our operations going as long as possible until the grid is restored.